Okay, so in this video we're dividing rational expressions, and most people get intimidated when they say dividing. For whatever reason, people don't like to divide. But when you're talking about rational expressions, all you got to remember is keep, change, flip. And what that means is you keep the first fraction exactly the same, you change divide to multiply, and you flip the second fraction. It's really that easy. And then once you do that, you have a multiplying problem like we did in the previous set of videos. So just factor, cancel out terms wherever you can, and just multiply straight across. All right, so again, in example 16, we have division in the middle, so we're going to keep the first fraction, change divide to multiply, and flip the second fraction. So let's rewrite our original problem. We keep the first, we change divide to multiply, and flip the second fraction. So x squared minus 6x plus 8 over x squared minus 2x. Now we're ready to do some scratch work. In my left fraction, again, be organized with your scratch work as always. There's nothing that can be done to 5x, so I'm going to just look at 3x minus 12, and I'm going to do that in green. There's more than one piece, so I'm going to try to factor it. If there's only one piece, most likely it can't be factored. If there's more than one piece, probably can. Here, I have 3 and negative 12. I'm going to look for a GCF, greatest common factor, which is 3. 3 will go into both numbers. So I can pull out a 3. On the inside, what times 3 will give me 3x? That's just x. What times 3 will give me negative 12? That's a negative 4. Okay, so the bottom of the left fraction will be written as that. Now we're going to do some scratch work for the right fraction. Okay, I'm going to look at the top first. I'm going to do the top in blue. X squared minus 6x plus 8. I have 3 pieces, so it's a bottoms-up method. We're looking for factors of 8. That'll add up to negative 6. So I'm going to say x minus 4 and x minus 2. I want to double check this by first multiplying negative 4 and negative 2, which is positive 8. And then double check it by adding negative 4 and negative 2, which is negative 6. So the top is factored. Let's do the bottom in green. We see more than one piece, so we got to try. X squared minus 2x. Let's scroll up a little bit, give myself some room. Again, I'm looking for greatest common factor, so I see they both have an x in common, so I'm going to pull out an x. On the inside, I'm looking for what times x will give me x squared. That's just x. What times x will give me negative 2x? That's a negative 2. So the bottom of the right fraction will factor also. Now we can use this information to rewrite our original problem. So for the left fraction, we had 5x, stayed the same. But on bottom, we had 3 over x minus 4. Okay? Times our right fraction, which on top became x minus 4 over x minus 2, or times x minus 2, I should say. And on bottom, we had x times x minus 2. All right, so now, before we do anything else, we want to try to cancel out wherever we can. Let's first look at the left fraction. I'm looking for identical pieces, top and bottom. Nothing in the left fraction, so move on to the right fraction. Looking for identical pieces, top and bottom. Well, x minus 2 and x minus 2. Those are identical, so they'll cancel out. All right, so now I've canceled out everything that I can so far. I'm going to now multiply again, just multiply straight across. So 5x times x minus 4. Do not do the distributive property. Leave it alone. Divided by 3 times x is 3x times parentheses x minus 4. Again, do not do the distributive property. All right, well, again, I want to try to cancel out wherever I can, so I'm looking for identical pieces, top and bottom. Obviously, x minus 4 is identical to x minus 4, top and bottom. Also, x is identical to x, so those will cancel out. But 5 over 3 will not cancel out. They're not identical, so my final answer for this is 5/3. I could leave it as a fraction, which you should, or if you really wanted to, you could round and turn it to a decimal. I say keep it as a fraction. Nothing wrong with that. Pretty easy. Remember, keep the original, change divide to multiply, then flip the second fraction. Once you do that, it's just like we did in the previous videos with multiplication. Let's try another one. Here we have a fraction divided by a polynomial. So the very first thing we need to do is turn this polynomial into a fraction. Remember, we do that by just putting a 1 on the bottom. Now we know anytime we see divide in the middle between two rational expressions is we keep, change it to multiply, flip the second fraction. It's always flip the second fraction. So 6x squared plus 7x minus 3 all over 6x squared. The first fraction stays the same. Change divide to multiply and flip the second fraction. So 2x squared plus 3x goes on the bottom. Now we're ready to do some scratch work. I'm going to look at the left fraction first. On top, I see more than one piece, so I want to try to factor it. I'm going to do that in green. So I have 6x squared plus 7x minus 3. I have 3 pieces. There's a number in front of my x squared, so I'm going to do bottoms up method. The very first step is going to be to multiply 6 times negative 3. So x squared plus 7x minus 18. Remember, the middle always stays the same. Now I'm looking for factors of negative 18 that'll add up to positive 7. I'm going to try x plus 9 and x minus 2. I want to double check this by first multiplying positive 9 and negative 2, which is negative 18, and then double check it by adding positive 9 and negative 2, which is positive 7. So the top of my left fraction is factored. On bottom of the left fraction, there's only one piece, so I'm going to leave it alone. Nothing can be done. Let's move on to the right fraction, some scratch work. All right, obviously on top is just a 1, so nothing can be done with that. But on bottom, I see more than one piece, so I need to try to factor it. 2x squared plus 3x. I want to start off by the first thing I notice is they both have an x in common, so that's GCF. I want to pull out the greatest common factor, the greatest thing they have in common, which I think is just an x. All right, so what times x gives me 2x squared? Well, that's just 2x. What times x gives me 3x? That's just a positive 3. So the bottom is now factored. All right, so now what I want to do is just rewrite my original problems using my scratch work. So on top I had x plus 9 times x minus 2, but nobody stopped me. I got a little carried away. I didn't finish factoring these two pieces. Remember, it's bottoms up. For bottoms up, you started by multiplying 6 times negative 3, so now to finish it, we have to take that 6 out by dividing. So I almost forgot to do that. Nobody caught me. Luckily, I caught myself. All right, so 9 divided by 6, we want to reduce that fraction. I'm going to just use my calculator. So 9 divided by 6, turn it into a fraction. That's 3 halves. So we end up with x plus 3 halves. But remember, in the bottoms up method, the bottom actually literally comes up. So now I want to say 2x plus 3 for that piece. Great. Now, same idea over here. I want to reduce this fraction, so negative 2 divided by 6. Turn it into a fraction. That's negative 1/3 right here. But in the bottoms up method, the bottom literally comes up. So we're going to say 3x minus 1. All right, great. So I'm glad we caught that. Again, this was our right fraction. I kind of erased my R, but that's all right. So now I'm glad I caught myself because that would have messed us up when we tried to rewrite this fraction and cancel terms out. So now let's rewrite our original problem using the correct factoring for each piece. So on top, in my left fraction, I have 2x plus 3 times 3x minus 1. On bottom, I just had 6x squared because nothing can be done with that. Times 1 on top over x times 2x plus 3. Okay, great. I'm looking for identical pieces top and bottom. I don't see any in the left. I don't see any in the right. So we're just going to multiply now straight across. Tops with tops, bottoms with bottoms. All right, so 1 times all of this is just itself. So we have 2x plus 3 times 3x minus 1. On bottom, I have 6x squared times x, so that's going to be 6x cubed times 2x plus 3. All right, so now I'm looking for identical pieces, top and bottom, and that's where I want to cancel out. 2x plus 3 and 2x plus 3 are identical, so they cancel out. So all that's left for my final answer is 3x minus 1 divided by 6x cubed. Now, do not say 3x divided by 6x cubed is 1/2 x to the negative 1 power, and forget about this minus 1. This is done. You can't do anything more. Finish. Leave it alone. Okay? Again, you can only cancel out if you have identical pieces, top and bottom. And that's it for this video.